The last video we talked about temperature. Now we are going to talk about heat. By the way, this is chapter 5. Okay. So heat is, what is heat and how does it transfer? Okay. The definition of heat, it is difficult to define what heat is. Okay. Let's look at this example. If you have an object that is at high temperature, and if you put that next to something in cold temperature, so this one is hot, this one is cold, what will happen? So in this case, if you put them together, let's say metals, if you put them together after a few minutes, they're going to have the same temperature. Okay, so there is something that is transferring from hot side to the cold side, and that quantity is called heat. Okay, heat, you can feel it, but you cannot weigh it. It's massless. Okay, all right, so let's see what happened. How can heat transfer? Okay, that's our next objective. What are the ways that heat can be transferred? There are 3 ways. The first one is called conduction. The second way is called convection. And the third way is called radiation. Conduction is when 2 things physically connected to each other. Okay, this way is called conduction, where you have an object at a higher temperature. If you touch that with a cold temperature material, then the heat is going to transfer from high temperature to low temperature. Okay, we can use the word diffusion to describe the heat. So it's always from high temperature to low temperature, and you always have to contact them together. What is convection? Okay, so for example, I have a beaker here, and I put fire under it. I have a candle. I want to make fire. Okay, when I heat it up, what will happen? The liquid in the bottom, when it absorbs the heat, is going to thermal expand. Okay, when it thermal expand, what will happen? We have learned that before. It will have a lower density. Why? Because with the same mass, and suddenly you have a bigger volume. So density is equal to mass divided by volume. When you have the same mass, but you have higher volume because of thermal expansion, so you have a lower density. When the V is higher, then you get a lower D. When the density is lower, guess what? The liquid that is in the bottom has a lower density, and it tries to rise to the top. Okay, when this one rises to the top, guess what? Somewhere it's going to go back down. Okay, so whatever liquid that is touching here, it tries to go up this side, go down this side, and it's going in a cycle. Okay, so this movement is called convection. Convection, you need a liquid medium in order for convection to happen. Okay, the third type is called radiation. So for example, how can we get the heat from the sun? Okay, so is that conduction? No, conduction is something to touch each other. We don't touch the sun. Okay, is that convection? Well, between the sun and the earth, this empty space is in vacuum. So it cannot be convection, because convection, there must be a fluid, okay? Either gas or a liquid. There must be some fluid. The third type is called radiation, okay? So most likely what happened is infrared radiation. That's where the heat is transferring, okay? So how do we apply this principle to engineer our product? Okay. So I have something like this in front of me. Okay, so this one, I'm not sure if you can see it. It's called a thermal flask. That's the trade name for this part. Okay, so what I need this is, I just take it from my kitchen, Okay, so this one, it can keep the temperature either hot or cold for a while. Okay, and how do we do that? I'm going to open one. They both can do a very good job. For example, I put hot coffee over here and I bring it to work. In the afternoon when I drink my coffee, it's still hot. Okay, so how do we maintain the temperature? Okay, so this one, okay, first of all, let's look at conduction. Okay, that means if we can use rubber to wrap this part so the heat cannot be escaped that easily. So we try to eliminate conduction. Okay, that's why this one, it would be better to be plastic or rubber. Okay, so it will not lose the heat that easily. We try to avoid these three ways of releasing the heat. Okay, so the first thing is try to make something out of plastic. Okay, now you will say, but this is not plastic. If you look inside, this is a metal. Why do we have a metal instead of plastic? Basically, the reason is not only to have a metal, but we try to make it shiny as well. It's not, the light is not good enough to see that it's shiny. Okay, but if you have a thermal flask, then you can look at it, because we try to minimize radiation. So infrared or any radiation in the visible area or infrared area, it can be reflected back. Okay, so see, if you have a sun over here, but you have a mirror, then when you stay on the other side, you don't feel hot. Why? Because the radiation would be reflected. Okay, that's why they have to make it shiny. The third way is to make it to eliminate convection. How does it done? Over here or the other one, if you use a metal saw to cut it apart, you will see that this one is not the same layer as the one inside. So I'm going to draw a diagram. I'm going to draw a diagram over. I'm going to erase this then. I'm running out of space. So if you dissect the cup, what you're going to see is inside it actually looks like this. This is a cross section. Okay, so when you put the liquid in fact, there's another layer like this. So why do we do it like this? First of all, this layer cannot directly touch with the layer outside, so we can stop the conduction. That's another way of stopping conduction. The other way is if we put it like this or put some foam in here, so the air inside or any type of special gas inside, it cannot do the convection that easily. Okay, so that's why sometimes the good one, they actually pump out the gas that is inside or pump out the air that is inside and make it vacuum. When it's vacuum, then you do not have convection. Okay, let me summarize how this thing works. It tries to eliminate the heat, the loss of heat by three ways. One is try to eliminate conduction. The other way is try to eliminate convection. And the third one is try to eliminate radiation.